Now we will talk about manhole sizing. Okay, so how to size the manhole as per our local codes. Okay, so if I talk about in my previous drawing, remember I told you everyone that you have a architectural project, right? Architectural layouts you have. Okay, so what is your scope? Normally you are going to find out all the wet areas. Okay, wherever there is a toilet or wherever there is a kitchen area or bakeries or whatever outlet. Okay, the wet areas basically. So you are going to find out that wet areas and you are going to decide what are the fixtures, right? Say for example, if I go here, I have what WC, I will be having urinal, I will be having say for example uh, uh, air conditioning equipments. Okay, from there I will be connecting all the condensate drain pipes. Then I will be having shops. Okay, so say in the each shop maybe there is a requirement of uh, catch basin. Okay, and then there are air conditioning machine. I will be having a condensate drain pipe. Okay, so this is the condensate drain pipe. Okay, then if I go to like a toilet area, I have a WC, I have a urinals. Okay, so what is my intention? Okay, wherever I have to collect all the waste pipe, I have to go to the nearest source. Okay, because what is my intention? Wherever the wastewater pipes, I have to collect from the fixtures to the discharge to the final inspection chamber. That is our intention, right? So what is our scope? Say for example, if I see one of the building, okay, I have an external network. You know that the external sewage network, then there is external network for the storm water, right? Okay, now what we are going to do, we are going to have a collect all the wastewater nearest to wastewater. Then I'm going to the nearest manhole. Okay, here. Okay, say for example, in this particular area I have wastewater pipe. Okay, so through the gully trap I'm going to the manhole. Okay, so then there is another wastewater pipe or whatever the pipes, I'm going to connect to the manhole through the gully trap, right? Okay, then if I go to this particular area, I have a soil pipe. So soil pipe will go directly to the manhole. So this soil pipe, if you go to the above floor, you have some toilet or something kind of thing. Okay, so the soil pipe is going to the manhole. Then after that, there is a waste pipe. So waste pipe will be going to the gully trap, then it will discharge to the manhole. Okay, then you can talk about here, there is a stormwater pipe. Okay, this stormwater pipe, this is called a free discharge. Okay, sometimes some of the project, what they will do, they will connect to the soil pipe to the manhole, but not the sewage manhole. They will connect to the storm manhole because the quality of the water is different for the sewage network and for the storm network. Because say for example, if you want to do the treatment, water treatment, then whatever the storm water you are going to collect, the treatment from the storm water may be lesser or different concept. Okay, and from the wastewater treatment will be different. So that is why we used to collect storm water separately and sewage water separately. That is the concept, right? So in this particular project, we have a free discharge, but some of the project you may connect to the manhole, stormwater manhole in the similar way. How I'm going to connect to here, right? So I will be connecting all the network, okay, whatever in the nearest toilets or nearest wet areas, I'm going to connect to the nearest manhole. So that is my intention, right? So here I'm going to connect. So here
Yes.
I have some wastewater, waste wet areas. I'm going to connect it here, right? So this is my intention. So based on that, I will be having a deciding my total manhole location. Okay, and what is the distance between the manhole maximum? We have seen in the code should not go more than 20 meter, right? Between the two manhole. So it can be lesser than, say for example, it can be 16.435. Okay, but should not go more than 20 meter. Okay, and the location of the manhole should not be in between. Say for example, if I'm going to have say for example interlock area, right? So in the interlock area I have to, within the interlock area I should design. Okay, it should not be off in the parking area, off in the interlock area. That is not good design, right? And I have to decide where is the best location for the manhole for the easy maintenance, right? Okay, then say for example, if I'm going to keep this manhole here, what will happen? I have to go with the heavy type manhole, right? The cover should be heavy type. So that means the project cost is going to increase. So if I keep that manhole in the interlock area here, I may go with the low type or medium type. Okay, because the project cost may go down. So that is why the choosing of the manhole location also important. Okay, and I'm going to choose the manhole location, but not exceeding more than 20 meter as per the local guideline. Okay, so what I'm going to do, I'm going to connect all the pipes. Okay, so there is a horizontal pipe. So this horizontal pipe, how I calculated? Remember, we have seen that IPC standard chapter 7, there is a table for the horizontal discharge, okay, and what is the total based on the total DFU, okay. So based on the total DFU, I can able to calculate my pipe size. Okay, so how to calculate DFU? Based on how many fixtures connected. Okay, you have a table, I give you Excel sheet. If you enter all the fixture quantity, you will get the DFU. So based on the DFU, go to the table, you will find what is the pipe size for the horizontal run. Okay, and depends upon the slope. If the slope vary, your pipe size will vary, right? So here, say for example, 1 is to 120 for 200 dia, right? So this particular project they have followed as per the local standard, right? So if you go to this
Yes.
particular one for the 200 dia, they have followed 1 is to 120, right? So this particular people they have followed the standard. So you have to try to follow as per the local standard. But if you cannot follow local standard, you should have a proper reason to explain to the authority that this is the reason we cannot able to follow. Okay. Otherwise, we must follow the local standard. Okay. So you are going to connect to the all the network pipes to the to the nearest FIC chamber. Okay, so this is going to cap it off for future connection. Maybe this will go to the FIC chamber, right? Okay. Now, how I'm going to size my manhole? There is a local codes. Okay, so if I go to this local code, it is given here. Okay, up to 300 mm depth. Okay, my manhole size will be 600 by 600. Say for example, if I go to manhole depth, okay, this is my depth. Okay, so up to 13 meter, I can go with the 600 by 600. Okay,
Yeah.
if I go more than 13 meter to 17 meter, then my size will be 1800 by 800. So I have to increase my manhole size, right?
Yes.
So if it is 1700 to 2500, then my size of the manhole will be 1000. Say for example, I have a further deeper, then I have to increase my manhole size, right? So if I go further down, 2500 to 4000 meter or mm, then I should have a 1500 dia manhole, right? Okay, so here it will be up to 1300. I have a 600 by 600 square manhole. 1300 to 1700, I have 800 by 800 square manhole. Then 1700 to 2500, I have a 1000 dia. It's a circular manhole. Okay, then 2500 to 4000, I have to go with the circular manhole, right? Okay, then what about cover? I have to go with the cover. All the cover can be 600 by 600 because it is a manhole. The people to enter, right? So the people, the minimum size will be like, or maximum size will be 600 by 600, right? Okay, so this is the manhole size. Okay, but now I have to calculate how much depth for each and every area, right? That I have to do the exercise. Okay, so if I go to one of the projector, okay, you can see that there is one Excel sheet. Okay, if you see this particular Excel sheet, you can see that the serial number, manhole cover, the distance between two manhole, okay, cover, uh, uh, NAD level, okay, cover level, okay, then the invert level, okay, the manhole depth, okay, then the manhole size, then the cover dimension, okay. So this particular one, this is as per local code. So if you go to local code, okay, you can also see here what is the distance between the two manhole, right? And if you go further, there is a table for the manhole, okay. So all the manhole shall be installed within the boundaries of the building plot. During the design, care shall
Can
be
you show
taken to
previous table? Can you show the distance between two manhole? The previously you showed
yeah. You can see this one. From the manhole to the manhole, the maximum will be 20 meter.
from manhole. Okay, manhole to manhole maximum.
Should be 20 meter.
Okay.
Okay. So that is why if you see my drawings, okay, you can see this drawing. This will be like a maximum 20 meter. Okay. Sometime maybe because of the coordination issue may exceed more than 20 meter, but it is not allowed. Okay. You have to have a, if it is going exceed more than 20 meter, then you have to have a in between additional manhole. Okay. Okay, but if you go to sometimes Saudi regulations, they may say that you can go up to 30 meter length. Okay, but depends upon the local code for easy maintenance, basically, right?
Yeah.
Okay. Now, say for example, if I talk about this particular schema table, okay, I have followed my manhole schedule as per the local standard, right? If I go this diagram, I have a manhole cover, authority, FIC chamber, manhole number, cover level, invert level, distance to next chamber, depth, cover type, everything, right? So here you can see that the first manhole, okay, what is the first manhole cover? It is like the NAD level, 0.15. This is the road level, right? So if I go to this diagram, what is the road level? Say for example, here it is 0.15, right? So this is the road level. This is the NAD level on the top. Okay. So if I draw one diagram, right? Assume that this is my road level. This is my road level, right? Clear? Okay. Now remember that every project having a 0, 0 level, right? Is that clear? Okay. Now if you see my road level, it is above plus 15, above the 0 level. So that is why if you see my diagram, it is plus 0.15 from the road, from the 0 level. So my road level is plus 0.15. So this is my road level, right? So this is my road level and this is my 0 level. Okay. Okay. Now, so what is the distance? Say for example, if I have any of the first uh, level, say for example, this is my, assume that this is my first fixtures. Okay. Or you can say that this is my first fixture. Assume like that. Okay. Okay. So what is the first fixture? What is the distance? Say for example, I have a gully trap or I have a catch basin. All right. So if you know the catch basin, assume that in the diagram, this is my, say for example, my catch basin. Okay. Okay. And this is my outlet of the pipe, right? Clear? Silva and Aditya, this is my outlet of the pipe. Okay. Now I'm going to run the pipe from here, right? So say for example, this is my manhole. This is my manhole, right? So I'm going to run the pipe from. Remember that when you see inside of the inside the manhole, you will see the section like this, right? Maybe if you see the detailed diagram, you will understand this particular section like this, right? If you see, you will be seeing like that. Okay. So now, say for example, I have to run my. I'm going to run my the waste pipe based on the slope. Okay. So this is my slope. Okay. And based on the slope, I'm going to connect to this network, right? To this particular line. So I'll be going in this direction, in this slope and in this direction. Okay. So if I go to the table here, okay, say for example, this is the distance between the manhole. So first will be, I don't have any distance. The first manhole. Okay. You can say any of the fixture. Okay. The cover level will be plus 0.15. And what is the invert level of the first one? 0.4. Okay. The invert level of the first fixtures. The minimum should be 0.4, right? Okay. So when I calculate my total depth based on the invert level, say for example, this is my point minus 0.4. So my pipe will be minus 0.4 here based on the slope. Okay. So if I draw, if I draw here, it will be 0.4 minus 0.4 meter, for example, right? Assume that this particular slope will be 0.4 meter. Okay, based on my
Okay.
length of the fixture. Okay, or I can say that this is my first fixture. Okay, so this is my first fixture. From the first fixture, based on the slope, my invert level will be minus 0.4. So this is my invert level. So what is the depth if it is 0.4 and this is the plus 0.15, right? If you see this one, what is the level? Plus
Uh, okay.
plus 0.15.
15,
Okay, so that means 400 plus 15, right?
1900.
Oh no, 550. 1400 plus 1400 plus 0.15, right? So manhole depth will be 5.55.
Oh, okay.
Okay, then the manhole size will be 600 by 600. If you go to the table, what is the depth up to 1300? I can go with the 600 by 600, right? So if I go here, it is
Yes.
only 0.55. So I can go with the 600 by 600. Okay, then manhole 2. So the next manhole, what is the distance to the next manhole? Approximate 5.85, right?
Table is in meter. That
Table is
table
in
also
meter.
is in meter.
Yeah, table is in meter. Yes. Okay. So the next hole will be
It
5.48.
is 1300 meter. It is going 1300 meter. 1300 in manual sizing table. For depth.
No, you mean this manhole depth? It is so 550 mm or 0.55 meter.
Mm. Yeah, that only answer.
Okay. Yeah. When you go to the next manhole, it is 5.85 is the distance between the two manhole. Say, for example, if I see the distance from this manhole to this manhole will be approximate 5.85. Okay. From this manhole to this manhole. So 5.85 length. Okay. So based on the 5.85 length, okay, and what is my new invert level? It is 0.45 because the invert level will be keep on going down, right?
Yes.
Okay, so now if you see based on this 0.45, what is the depth, new depth for the next manhole? 0.45 plus 0.15. So total will be 600. Okay, so up to 1300, I can go with the 600 by 600. So this is the next manhole size. Then what is the next distance between the next manhole? 17.37. Then what is the cover level? 0.15. And what is the invert level? 0.59. And when you do the difference, it will be 74, 0.74. So then again, I'm choosing 600 by 600, right? Is that clear, Aditya and Selva?
Yes, sir. One thing in the rough diagram you drawn, you drawn carry basin. So in ground, we use
Sorry,
carry basin
your
or
voice is not clear, Aditya. Hello?
sir,
Hello? Yeah, tell me, what is your clarification?
yes, sir. In the rough diagram which you showed by lines,
Okay.
so you drawn catch basin, catch basin. So do we use catch basin in ground level or I saw soakaways also. So what we will use soakaways or catch basin in the rough diagram you drawn, na, for
No,
explaining
no. No,
about that.
this one.
Yes, yeah.
No, no. What I'm saying is, see, say for example, I told you as per the drawing, you have a manhole, right? You have a manhole near to say any
Uh-huh.
of the fixture. Okay. So this is any of the fixture, any fixture, either have catch basin or you have a gully trap or whatever the fixtures from the
Okay, okay,
fixtures to
okay,
the manhole.
okay.
Okay. So then, based on that, you have a slope, right? You have a invert level, that every pipe having invert level, right? Say for example, if I
Uh,
go this particular diagram, okay, I have invert level here. See, for example, point 0.4. But if I go further down here, minus 0.45, right? If I go
yeah,
further
I,
here, minus 0.59. So this
yeah, I
particular invert
understood
level,
this one. Sir,
okay,
but my question was, do we use catch basin in ground level also? Ground level means in generally catch basin I saw in podiums.
so no, no, no. See, just for example only, I told you there is no
For
catch basin.
example, okay.
Yeah,
And
this is the
sir,
cleaner.
what about soakaways? What about soakaways? What is that? Where we will use soakaways?
See, Soakaway normally, say for example, you have a rainwater pipe, storm water pipe, right? Okay,
Okay.
and sometime you have a free discharge in the outside. Sometime you have a network connected to the manhole. Okay,
Uh-huh.
okay, but sometime what will happen? You don't have any choice available. You cannot have a free discharge, and also you cannot have a network. So what you will do? You will make a one type of like a rectangular box with all
Okay.
stones, everything, which is connected to the underground water. Right? It will go to the underground. Like you can say that this is like say for example you have a manhole kind of thing, okay, and inside you have a lot of stones or whatever you are
Yeah.
going to create some I have a sample. Okay, let me try if I can
In sir, that Dubai building code, the diagram is given. Soakaway.
the Soakaway, let me open if I you know where it is.
Yeah, yeah, above. You can go above. Somewhere here only. Here only I saw. Or go below, sir. Here only in the drainage section only soakaways over there. In drainage section.
This is the grease interceptor. Okay, one component, and this oil
Mm,
separator. Okay. Yeah, can you see
this.
here Soakaway? The same thing, like we
Yeah.
have a manhole kind of thing, and it will be discharged, whatever the water you are going to discharge, it will go to the soil down.
Mm-hmm.
So this is not a free discharge or you're going to connect to the network. This is directly on the, like you're going to create a, like a small, say for example,
Filter
uh,
type, like.
yeah, filter type. Yeah, see, once the surface drain water flow flow shall be discharged into a soakaway. The foundation level of the base of the soakaway shall be kept at 1 meter. You can see that this is the soakaway, like 1 meter. Okay, the soakaway shall be located at least 3 meter away from building footprint of a building. Soakaway shall be filled with boulders that are 75 mm to 100 mm in size. So this is called like stone kind of things, right?
Mm-hmm. Yeah.
So this particular manhole they will arrange it at the site. Okay, so this is
Okay.
call it as a soakaway. Okay, there are different terms available as per the architectural. Okay, but you can see here as well the soakaway, right? So whatever the
Mm.
water, it will go to the infiltered by the sand. Okay, then that particular water can be reused for other purpose, right?
Okay. Okay.
Okay, so that is the some of the project. But normally in our UAE project, we may there is no much project in Soakaway because we
Uh-huh.
have a network, nearby network, and also some of the project we have a free discharge, right?
Yes. Yes.
Okay, so if you see the manhole to cover, say for example, now you will be keep on going to the manhole to manhole, right? Manhole to manhole, manhole to
Yeah.
manhole. Okay, so based on that, you can able to size the manhole size and also cover dimension. What is the type C, medium duty? If you are going to put it on the car park, then it will be heavy duty, right?
Mm-hmm.
Okay, so this is the way to select. So you also try one time based on your layout. You can enter the manhole reference number, enter what is the distance between two manhole. Okay, what is the cover level based on the road level. Okay, and what is the invert level of the particular area pipe, right?
Mm-hmm.
So based on that particular area pipe, and you can decide what is the distance. Okay, from road level to the invert level of the pipe. Okay, then you
Good.
can decide what is the manhole depth. So based on that manhole
Uh,
depth, you can go with the what is the size required. Is that clear?
okay. And does the
So
pipe size, how for the pipe size between two manhole, how that will be
no,
calculated?
that is based on the discharge DFU calculation. Say for
Okay. Okay.
example, okay, say for example, I have this is a one manhole, right? So in this
Mm-hmm.
manhole, what I'm connecting waste pipe, for example, right? So in this
Mm-hmm.
waste pipe, I know how many fixtures connected, right?
Mm, yes.
So based on that, I know what is the total DFU.
Yes. Yes.
So based on the DFU, I can calculate what is that pipe size for horizontal. If
Mean
I go to
pipe.
the table,
Yeah.
okay, then I
Yes.
will go further down. Okay, further down, then I will be collecting another waste, another drain fixtures.
Okay.
So I will
Okay.
be adding,
Okay.
keep on adding the drainage fixture. Okay, but if you go to the
Okay.
ground, if you go to the horizontal riser, normally as per the local code, it is like 200 mm or 150 mm size. Okay, if I go to the see, this is for the sanitary fixtures. Okay. Uh, okay, this is for the riser up to 7 story. This is the riser more than 7 story. Okay, but for the riser, it is based on the DFU calculation. Okay, then based on that, you can able to calculate what is the pipe size between two manhole. It will be normally 100 dia. Say for 150. See, in this case, okay, you have 100 mm diameter, right? 100 mm diameter connecting to the your network. Okay, and also remember when you go to the the BS standard, there is a velocity chart, right? Let me open the BS standard. So if you go to this BS standard, there is a velocity for the wastewater pipe.
कम करना है आवाज.
Can you see the velocity of the pipe? See, approximately it is 0.5 to 1.6 meter per second. The capacity of drains. Okay, so
Mm-hmm.
the slope depends upon the slope I can increase the pipe size and my velocity will be increasing, right? Say for example, if this is very concept, right? I'm going with 100 dia pipe, okay? And if I increase the slope, my velocity will increase, right?
Yes.
So this is the accepted velocity of the drain. So whenever you calculate your drainage pipe, you can calculate based on the capacity of drains, how much capacity of drains, how much liter per second, and based on the liter per second, you can decide whether it is 150 dia or 200 dia. So here there is a flow is there. This flow, how you calculate based on the discharge unit calculation, right? Discharge calculation,
Yeah. Du.
du. So based on the du, you know the flow rate. So based on the flow rate, you can able to decide what is the velocity and what is the diameter you have to go.
Yes.
Okay, so this is one of the concept, and also IPC standard. You have a table, right? You have a table. If you go to this table, chapter 7, it is clearly given here. Horizontal fixture branches and stacks. This is the one. Okay, and if you see here, maximum building drains and sievers. What is building drains and sievers? That is this one. That is this. This is a building drains and sievers. Okay, right?
Okay.
And inside you have horizontal fixtures. Say for example, if I go to inside a building, there is a horizontal fixtures. Okay, so that is this particular
Mhm.
pipe. That is this particular pipe, horizontal fixture branches. And then we have a stack. Stack is a riser pipe, right? So we have a horizontal
Yes.
fixture branch, we have a stacks, and then we have a building drains and sewer. So we have a table here.
Yes. Yes.
So based on the DFU, you can able to calculate how much. Say for example, I have a 200 dia pipe. 200 dia pipe is nothing but 8 inch, right? So for 8 inch, if I go with the building drains, say for example, this is 8 inch, right? So if I go with the 1/6 inch slope, I can connect up to 1400 DFU. 1400 DFU. Okay. If I go with the 1/8 inch, then I can go with the 1600 DFU, right? If I go with the 1/4 inch slope, I can go with up to 1920 DFU, right? So this is the concept.
Yes.
Okay, so you have to decide what pipe size you have to use it. Say for example, maybe sometime based on your calculation, maybe the pipe size will be 75 mm, but based on the riser, I have 150 mm. So what I will do, I will go with the next higher size. Okay, so always you have to check the local standard and also you have to check the calculation. So which is higher, you have to apply in your diagram, right?
Hmm.
Okay, so this is the way you have to calculate all the manhole sizing. Okay, manhole size and the pipe size, everything you have to connect to you have to discharge to the nearest FIC chamber. Whatever you are going to calculate, you have to direct it towards the final inspection chamber, either sewage pipe or storm pipe. Okay, is that clear?
Yes. Yes.
Okay.